Ladies and gentlemen, boys and girls, children of all ages, we have been multiplying fractions and whole numbers this week. We've learned a couple of things of how to do it, a couple of different ways. You should know where we do parts of a group. That doesn't always work. You should know how to use a number line. You should know how to do repeated addition. So those are three of the ways that we do it. There is a standard algorithm, but I haven't even taught you that yet. Not yet. I showed you if it divides in evenly, but like 3 doesn't divide into 7, so you can't use that standard algorithm. So let's look at parts of a group first. The first problem we have up there is 3/8 of 7. Now remember, of is the same as multiply in this case. So it could be 3/8 times 7. Our denominator tells us how many groups we're going to have. I can have groups vertically or I can have groups horizontally. The important part is to be able to identify the way the groups are going. And so a suggestion, if you're doing it and have to do it, I'm going to number my groups. I have to have 8 because that's what my denominator says. So 3, 4, 5, 6, 7, and 8. And I have to have a total of 24. So I could do it, once I know my 8 groups, I could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. So then we have to ask ourselves, how many are in each of the groups? 3. So 1/8 of 24 equals what? 3. If I have just 1/8 of 24, it's going to have 3. One of the 8 groups is going to have, so 1/8 of 24 is going to be 3. This problem asks for 3/8 of 24. So then I circle 3 of my groups, and I simply count 3/8 of 24 is how much? 9. 3/8 of 24 equals 9. Easy peasy, raw chicken squeezy. Now, yesterday or the day before, we learned about number lines. Number lines. The number line is helpful to use when you don't, this one could divide into 24, and then we could multiply by 3. This one, 3 is not going to go into 7. So we have to use a number line for this, or a different way to do it. So I'm going to make my number line 1, 2, 1. 1, 2, 2. 1, 2, 3. 1, 2, 4. 1, 2, 5. 1, 2, 6. I don't know how long I'm going to have to do my number line. Now, why did I put the dashes like that? Anybody have an idea? Susankia?
You can see if the number is a whole number. Is like a whole number.
Yeah, but I can put 10 dashes between here. Why did I only put those 2?
Because you're showing the fractions.
Okay, Drea? Good. My denominator, I'm dividing my number line up into thirds, because that's what I'm going to count by. I'm counting by thirds because my fraction is 2/3. And I have to count by thirds 7 times. So I could go from 0, 2/3, 1, 2/3, 1, 2/3. So 2/3 times 3 is 2. I got to do this 7 times. 1, 2, 3, 2/3, 4, 2/3, 5, 2/3, 6, and 2/3, 7. So I've counted by 2/3 on the number line 7 times. Okay, is my answer greater than 3? Yes or no?
Yeah.
Greater than 4?
Yes.
Greater than 5?
No.
No, so my answer is between 4 and 5. Is my answer going to be a whole number? No. Okay? It's 4 and how many? 4 and 2/3. Because each dash is a third, or each of these marks is a third. So this is 1, 1 and 1/3, 1 and 2/3, 2, because 1 and 3/3 is 2. Okay? So that's my number line example. We can also, because multiplication is the same as repeated addition, it's the same as repeated addition. So I could do, for this problem, 4/5 times 6. I could just do 4/5 plus 4/5 plus 4/5 plus 4/5. 1, 2, 3, 4 plus 4/5. 5 plus 4/5. That's 6, right? All right, what?
In the beginning, I asked you.
In the beginning.
I asked you if we could do that, and you said you couldn't.
Oh, maybe I wasn't ready for you. Maybe I wanted you to know the other way. Maybe I just had a bad day and I fell on my head and I had amnesia and I found out that I was really mean to all the kids before and I chased a kid away to Melton. Oh, that's a book. Never mind. All right, so how would I figure out the answer to this? Add. 4, 8, 12, 16, 20, 24/5. 24/5. I can't leave it as an improper fraction. I got to make it into a mixed number or a whole number. So how many times does 5 go into 24?
4.
4 times. And how many are left over?
4.
So 4 and 4/5. So those are 3 of the ways we've learned to do multiplication of fractions in whole numbers. Some will work this way. Now they're all going to work this way and this way. But if I had to do 2/3 or 4/5 times 210, I don't want to have to make 4/5 times 210, 4/5. All right, the actual working, I showed you how to do it with this, where you divide and then multiply. But Susankia drives me crazy and wants to know, well, what is the standard algorithm, Mr. McMurdo?
Yeah, I do.
So I'll show you the standard algorithm here.
Yeah.
I'm going to write that up here. Standard
I would trust you.
algorithm. Algorithm. Is that right? I don't care. All right, standard algorithm. Susankia, give me a fraction.
10/13.
10/13. Now give me a whole number.
2.
Okay. 10/13 times 2.
Or up to.
Or 10/13 of 2. Now the actual standard algorithm. Can I make 2 into a fraction?
Oh, yeah.
How?
Okay. 2.
Oh, you just.
Emma?
You make it an improper fraction. So you'd split it. You make it an improper fraction because right now it's simplified.
Okay. So how would I make it an improper fraction?
You could divide it by halves. No, or do that.
If I put any whole number over 1, that's a fraction. Because if I gave you, I'm saying I have 2 1s. How many is that? 2 1s. It's 2. So now, Susankia, and I will tell you, we have multiplied a fraction times a fraction before. Every time I find equivalent fractions, that's what I'm doing. So now I have 10/13 times 2 over 1. And like I told you before, multiplying fractions is so much easier because I just multiply straight across. 10 times 2 is 20. 13 times 1 is 13. So I can make my whole number into a fraction by putting it over 1. Multiply straight across, but I get what kind of fraction? Improper fraction. So how many 13s are going to go into 20?
1.
1
and 7 over 7.
and 7 13s. So there you go, Susankia. That's your standard algorithm.
Thank you.
No, thank you, Susankia, for just being you. Boom, shakalaka, peace out. God bless. Love you. Do something kind today. Please subscribe and bring your teacher. I don't know, 9 Dr. Peppers because, he deserves it. He's a good guy.